Welcome back to 10 Applied Math. Today we're going to continue solving linear systems using the method of elimination. We started off by solving linear systems using graphing, and very quickly we realized that solving systems using graphing won't work when our x and y values are fractions or decimals. In that case, we have to resort to an algebraic method that will allow us to find exact values for x and y so that we have an exact solution. In our lesson from last day, we went through eliminating one of the variables by adding the two equations together. Now, if you look at the examples that we have here, if I try to add these together, x and x would give me 2x, and a -2 plus 3y would give me positive y. So adding these two equations together is not going to allow me to eliminate either the x or the y values. So we have to come up with another method once again. So we're still using the concept of elimination. However, instead of adding the equations today, we are going to subtract the equations. So like last day, you'll notice that our equation A and B were all lined up where the x coefficients, the y coefficients, and the constants are lined up in the same position. So what we're going to do is this time, instead of adding, I'm going to take equation A and I'm going to subtract equation B. So x take away x will give us 0x. -2 subtract 3y will give us -5y. And -9 subtract 16 will give us -25. And you can see, because the coefficient, the number in front of the x is 0, by subtracting the equations, this time we have eliminated the x terms. So we were left with then -5y equals -25. We divide both sides by -5 to find that our y value is +5. We have now found one part of the ordered pair. We have to find its counterpart x, and to do that, we are going to substitute y equals 5 into either equation A or equation B. Now, I can go in either one because it's a common point. So to find x, I'm going to substitute y equals 5 into either A or B. I'm going to choose A. So that becomes x minus 2, replace the y with 5, equals -9. This becomes x minus 10 equals -9. We are going to transpose the -10 to the opposite side and make it positive. So x will equal +1. So our solution then, xy, is equal to the order pair 1, 5. Okay. Now, we need to verify that this, in fact, is the correct solution, doing a formal left side, right side check. So we'll do a formal check to verify that we have the correct solution. So we are going to be substituting x equals 1 and y equals 5 into both equations. So for equation A, the left side of the equation is x minus 2y. And the right side is y equals -9. That is based on the original equation that we're given. Now, on the left-hand side, we are going to replace the x with 1 and the y value with 5. We clean this up, performing operations based on order of operations, so multiplication first, followed by subtraction. So 1 take away 10 is -9. The left side is equal to the right side. So I have verified that 1, 5 is indeed a point on line A. But I also have to go through the process and I have to check equation B as well. So here, the left side is equal to x plus 3y. I'm always starting off with the original equation, the way the line was presented in the original equation. So we're going to replace x with 1. Our y value is 5. We're going to multiply And then we're going to add, and you can see the left side is equal to the right side. So I am confident that this is the correct solution because I've done a formal check in equation A and equation B. Okay, let's look at a second example. So here, again, if we add these together, we're going to get a 6x and a 6y. So we wouldn't be eliminating any variables. So we can, in fact, then use subtraction. And the reason we can use subtraction has to do with the fact that these two terms are the same. So if you're giving away or subtracting something that you have the identical amount, then you're going to be left with a 0. So let's proceed to subtract our equations. 2x take away 4x leaves us with negative 2x. 3y subtract 3y leaves us with 0y, and 8 take away 4 is 4. This cleans up to give us negative 2x is equal to 4. So x is equal to negative 2. Now we find the y counterpart. To find y, substitute x equals 2 into either A or B. Let's put it into B. I'm always choosing A. Let's try B this time. So we're going to replace x with negative 2. We're going to multiply. I'm going to transpose the negative 8 to the opposite side. Collect like terms once again. Divide both sides by 3 to find that y is equal to 4. Our solution then is xy equals negative 2, positive 4. And if you want to make sure you have the correct solution, you're going to do a formal check in both equations. So let's check in A. The left side would be 2x plus 3y. So x is negative 2, y is 4. And the right side is negative, oh, sorry, the 2x plus 3y, the right side is equal to 8. I was looking at the wrong question. Okay, so we need to clean up the left side, multiplying first, gathering like terms, negative 4 plus 12 indeed equals 8. So the left side equals the right side. We have just verified that negative 2, 4 is a point on line A. Now we're going to verify in equation B. So the left side is equal to 4x plus 3y. This is a time-consuming process, but it's certainly good practice. And the right-hand side is equal to 4. Okay, so order of operations says deal with your multiplying first. So the negative 8 plus 12, collect like terms. The left side is equal to the right side. So we have verified that negative 2, 4 is a point on line A. It's also a point on line B. And because it's a common point, it must be the solution to our linear system. So we've looked at elimination in terms of sometimes we add the equations and there are other times that we subtract the equations. In the homework for tonight, the questions will always be about subtracting the equations. But I want you to look back and see if you can come up with criteria, meaning what are the conditions that are required for you to add equations and what conditions must exist in order for you to subtract the equations. How do you know when to add equations and how do you know when to subtract equations? So as you're completing your homework, think about that particular question. Okay, when do you add equations and when do you subtract equations in order to eliminate a variable? That's where we will pick up our discussion next class.